I'm pretty much unable to think at this point because I spent the last 10 minutes stretching my German skills. And the nice thing, like once I went to a conference in Poland and I watched an entire day of Polish programming talks. I can't remember, is anyone here Polish? Yeah? No? Oh, that's too bad, because I was going to ask for help. There's, the ing on the end of words in English, like programming and developing. It's something like Andi or something, and so they just put the English word and Andi on all their slides. So programmer Andi and Rails generate Andi and that sort of thing. It was fun. That's all I took away from that one. This one, though, I learned that when you say in German, neue Services, it sounds like annoying services, which I think is probably relevant, probably a good, happy accident. You can tell I'm not a professional because I don't have a proper title slide. I apologize, but I have a tweet. I saw this, I guess this was in 2015, based on this link. This is one of the partners from Sequoia Capital. Sequoia was our investor. I was a CTO at Wunderlist. We were acquired by Microsoft last year. I'm really bad about introducing myself. I didn't drink before the thing because I wouldn't want to impair my performance, but if I do it now, I have some time, so I have to hurry up and speak, just so you know, being very professional. Anyway, the Sequoia Capital is one of the most successful venture capital companies in history. On our board, we had Michael Moritz, Sir Michael Moritz, who was a knight, actually, in England, because he's so successful. So I followed various people from Sequoia after they invested in us. And I saw this last year, where this guy tweeted this article that he wrote in Wall Street Journal about microservices being the future of how enterprises build software. And at that point, I thought, I'm going to capitalize on the next wave. So I'm planning my next conference. It's Small Method Conf. So it's all about, when you write methods in your Java code or your C#, just keep them small. This is the new wave of software development. It's going to be held in Berlin on Christmas Eve. So please come to this. What I really thought, though, was, what the hell is he talking about? What does microservices mean in this context? Like, why is there a partner at a very successful venture capital firm writing an article about microservices in Wall Street Journal? Like, who's reading Wall Street Journal? I don't know them, but they're not people like us in the room. They're not doing our jobs. You shouldn't be thinking about it. Someone is missing the point. And just so you know, I gave this talk, a version of it, a smaller version of it, at a conference called SpeakerConf in Anguilla, which is in the Caribbean, in November. And that was the last time I did a conference talk. And SpeakerConf is a small invitation-only conference that has, I think, like 20 people max, something like that. It is the place where speakers come, they get together, and they talk about what their idea is that maybe they're going to be talking about in the future. It is the place that microservices as a term was born. Fred George has been to this thing maybe every time, I don't know. And he was there when I gave this talk. And so I put this slide in for him as an alternate title for my talk. Kill microservices before it's too late. And I put it in quotes because it's not that you shouldn't do microservices, but you shouldn't do microservices. Does that make sense? I think this translates pretty well, right? The reason for that is I've observed something over the course of my lifetime/career, and I'm just linking to my blog here, but it's an easier way than making a slide. When you you have an idea that is like somehow disruptive, and you want to convince people of it. So like test-driven development or behavior-driven development. It's a thing you were already doing, but somehow people didn't get it, so you needed a marketing tool. So you made this term, agile software development, for example. And you use that to get everyone talking about it. And that's when it gets in Wall Street Journal. But what immediately happens is that people take that term and they use it as a proxy for doing the right thing. In the same way that if you get a Fitbit, you're still going to be fat. You're just going to know that you're walking more steps or whatever. It doesn't matter. It's a proxy for the right thing. So microservices, I would argue, is a proxy for the right thing. And I've seen it now in the big company where I work. I won't say more of that, but I've seen evidence of this in the industry, that people are saying, you need to do microservices. Should we do microservices? Yes, let's do microservices. What's your microservices strategy? So we need to be very careful about that, because microservices was for Fred really just a marketing tool to get people to start doing small things. But he didn't want you to do small things. He wanted you to reduce coupling. That's really what it's about. That is the goal of microservices. If you're not doing that, it's kind of a waste of time. We joined Microsoft a little over a year ago, and I have radical ideas about how technology should be built, and I've sort of spread them around to various people, which causes other people to ask me to speak to team after team, and pretty much all of them are left kind of offended when I'm finished speaking with them. But what I've discovered from each conversation is that coupling is the biggest problem we have as a company. And I'm pretty sure we're not alone as Microsoft. I've seen it in my entire career that software is pretty much built to be coupled by default. In fact, I went to this wonderful talk by a guy named Reginald Braithwaite Roggenwald in the Ruby community, where he talked about Ruby, which is where a lot of my background is, and says, Ruby makes beautiful coupling, which is kind of an interesting way to think. Like, it's beautiful, but it's also deeply tightly coupled the way you build things in Ruby. Because of the freedom you have at runtime. So here's another alternate title for this talk that really I just spent the whole time at SpeakerConf giving alternate titles for the talk. But the system is the asset and code is a liability. And you should think about this a bit, because most of you are software developers, I assume. Are you all software developers? Not everyone. I shouldn't do that, because if you're not, then you're going to feel superior to everyone else. System is the asset, code is the liability. We fetishize our code, and we forget about the system that we're building. And that's sort of a key part of the philosophy that I'm getting into. And so here's the real thing that I've arrived at. And it's because I started thinking about like small and microservices and coupling and all these things, and it comes down to this. But I'm going to talk to you with a very specific viewpoint, and it comes from sort of two things. One is my experience rebuilding Wunderlist after I joined as CTO. The next is an exploration of the ideas around biology and how we might apply them to build software that can survive for a long time. And my time at Six Wunderkinder building Wunderlist, those two things merged. And so this is really the project where I took everything that I thought I knew at the time, like in one grand gesture, and tried to build something right. And yeah, it's actually kind of worked out pretty well. Here's what the Wunderlist architecture looked like when I started in 2013. The company had just launched Wunderlist 2. It was a big rewrite. They had gone from a monolithic PHP backend and titanium appcelerator front end. I don't know if you've seen that, but it's this old kind of crufty cross-platform development system where you build things in HTML and JavaScript and generate iOS, Android, etc., to a Rails monolith in the cloud and native clients. So the clients were beautiful and the launch was a success, except for the fact that the backend could not survive the launch. Because our marketing team is, I always say, pound for pound, the best marketing team in the world, meaning extremely talented but also very small. So when we launched Wunderlist 2, there was all this buzz and hype. It was featured globally. It was wonderful, except no one could actually log in. No one could create an account. And probably you've all experienced some sort of outage situation. Imagine it's Christmas and you've been down nonstop for a week and you don't know what to do still. And it's literally Christmas Day. That was Wunderlist before I joined. And it was riding on the back of this fabulous architecture. It's called the two-bubble architecture. It's a database and then a blob. And so after some time of keeping the thing alive, sort of getting it into a semi-healthy state so at least people could use it, we built something that you would draw a diagram of that looks sort of like this. There are actually maybe 100 circles missing from this. And yes, it's just a to-do list. I know it's ridiculous, but we had multiple layers of microservices. We had a front-end layer that only did REST stuff and it handled authentication, authorization, that sort of stuff. We had another layer that was like a REST interface directly to the database, giving you standardized ways to talk via HTTP directly to database as a super user. We had this really beautiful message queuing system. We have it. I shouldn't say we had. We still have it. It's beautiful. It is the best thing that I've ever built. It is, like, it worked out. It's one of those things where I'm not going to tell you that I foolishly went in and tried to do everything I thought was right and failed. It's a boring story. It worked. It worked so well that when we launched, we thought no one was using it because it just worked. We were like, what the hell's going on? But here's the interesting thing about it. When we launched into this rewrite, one of our older investors, and I don't mean old age like me, but like old in the company, he had been through this 3 times already through the company's history. And when we told him in a board meeting that we were thinking about rewriting the system, you could hear through the phone line the anger boiling up before he even said anything. And when he spoke, he just like barely held back the rage and said, "Please tell me you are never going to say this again. This is the last time." And it was clear like he was going to hurt us or something if we told him this again. So I said, "Matthias, if you hear that we're doing a rewrite like this in the future, even after I've left, you can shame me out of the industry. I promise this is the last time. I'll leave the software industry altogether. This will be it. You can fire me from the company, but then even just like tell everyone I suck, never hire me." And I think that made him feel better. Within a year of launching this, we had rewritten 80% of the software in the system. But Matthias didn't know it. And it was actually, that fact is something that I'm very proud of. Not the fact that he didn't know, because I did actually tell him ultimately, but the fact that it didn't matter and the fact that it changed that much in a year. Because what do we want out of maintainable software? We want software that can change, right? Software that can change, software that can adapt. We had rewritten it partially for fun, because we were really tired of just working on this hell project and trying to get it out, you know, the Death March style project. So we wanted to have some fun. We wanted to try some new technology. But we also rewrote it so that we could save hundreds of thousands of dollars in infrastructure cost per month, which we did by rewriting 80% of the software on the side as a separate like fun project kind of thing. So this takes me to this other metaphor that I came into the company with. So I came in with this point of view where I was thinking about the word legacy. And actually my friend, DHH, David Heinemeier Hansen, who made Rails, he used to post things about the word enterprisey and try and get us all to hate the word enterprise in software, you know, and he would always say like, it should be the new version of legacy, where you tell someone you work on legacy software and they cringe, you know. No one's proud of being someone who works on legacy software usually. And I always thought that was sad because coming from a music background, as I am, you know, I'm not trained in software development, and I had this other career first where I was playing saxophone. For me, the idea of leaving a legacy sounded very appealing. Like, you know, John Coltrane, Charlie Parker, I don't know, David Bowie. These people have left a legacy. It's a good word, legacy. It's like an inheritance, so something you leave for future generations. But you come into the software world and it's just like a horrible thing that has been strapped onto your back without knowing it, and you have to carry it around for the rest of your career. So I started thinking about how can we turn the word legacy into something good? How can we build software that can survive for a long time? And some of you may have seen, I've done some talks about this where, you know, I say the average lifespan of a piece of business software is about 5 years before it gets thrown away and rewritten. I have spent much of my career rewriting software in these ways, like the Wunderlist rewrite. And it really sucks, because when you're doing it, you're taking, like imagine the project you're working on right now. Let's say you're building something new, the last time you built something new. You're working hard, you're stressed out about it, you're emotional about it, you get in arguments with your team members about it, you know, you complain about how that person writes code or the designers do this, and in the end, hopefully you together feel good about what you've launched, but it's almost like giving birth. You know, you're working so hard and you're thinking so hard about it, you're putting yourself into this software. In 5 years, someone's gonna come around on average and just destroy and throw away all of that work, all of those hours, all of those emotions, all of the thought that you put into it, which means right now you might be wasting every moment of your time. which is really sad. So I wanted to think about how we build things that survive. And I looked at myself and thought, well, somehow I'm 40, or now I'm 42. I don't deserve to be alive. I'm not taking care of this system, but somehow here I am. So there's this whole biological metaphor concept that I started digging down into. I have to admit I don't really understand the science of it that much, but the way it works is you go and you find metaphors that you can grab onto and they make you think, and that's what happened to me. So the first thing that got me really excited is the concept of homeostasis in biology, which, to overly simplify, is an organism's ability to basically self-regulate. So you have different organs in your body that need certain things and produce certain things, and some of those are in conflict with other organs in your body. And if one of them is not regulated properly by this system, it will do too much and basically make you die. It puts you into a state of homeostatic imbalance. And this concept sounded really interesting to me because I thought, what if we think about systems like in the microservice world as organisms, and all of the connections form this body, and there should be this way to regulate the body so I don't have to do it. And I know that people are doing that now. Like, I'm a venture capitalist now too, weirdly enough, and I'm meeting teams that are building software that does this for you. However, although I got so excited about this, we never actually worked it into our software because this concept was so powerful. And yes, there was a slide similar to this. Mine is not as good as the slide in Jan's presentation, but the concept of cells and regeneration of cells. So right now, there are, I don't know how many people in here, there are trillions upon trillions of cells dying in our bodies collectively every second right now. Trillions per second. There's so much death in this room. It's disgusting. But that's the way it's supposed to work. You hear, from when you're a kid, you're not going to be the same living being by the time you're an adult physically as you are now. It's actually not totally true. There's some part of your body that survives that's unsurprisingly in your brain. But most of you is replenished. And if it weren't, you couldn't continue to survive. And you look around the rest of the world and you see the auto industry and other places like this, where yes, the parts of the car break, but the car is still the car. It's still my crappy Volvo station wagon, but now it has a new whatever, I don't know anything about cars, but you get the idea. This is the thing that stuck with me so well, and I started thinking about, okay, if I want to build a system to survive, it has to be made up of cells that can be regenerated, and that's how we make change. How can I regenerate cells in my code? And there are two ways. You can think about it at runtime and at code time. And we'll talk about code for a moment. When you're coding, a cell in your code is some component, and to regenerate it is to throw it away and rewrite it, as one example, right? When was the last time you, in your production software, just took one piece of the code and said, I just want to rewrite this, I'm just going to do it right now, and then you just did it and deploy it? Probably not very frequently. Some of you would be able to say very recently, but in general, it's not a thing that we do in software because we think we're supposed to create the code and it's supposed to work, and we just keep it, and maybe we maintain it, whatever that means. But that's the opposite of what we're looking for. We want to be able to change code. So the best way to do it is to have tiny little components that we can change. If it's this big, throw it away. It doesn't matter. And if you can't see me, I'm just holding my fingers up as far as they can spread. If it's just a few lines, you're not going to be afraid to throw away your code. It's not wasteful to throw away 5 lines of code because you can remember it or just write it again. Hopefully the methods are named well enough or whatever. So I got really enamored with this idea of tiny bits. And this was independent of Fred George. We were off doing conference talks about this same thing, but I didn't come up with a word like microservices, so I failed and he succeeded. But I got so excited about it that I thought, maybe all we need to do is think about things being small, and that's the key to doing everything right in software development. I did this talk, this was at Code Mesh a couple of years ago in London, which is a great conference if you can get to it, for really nerdy functional programming and kind of futuristic programming stuff. And one of the things that I went through was a list of phrases that might not sound right to you. Dissonance means a noise that doesn't quite sound right. So this one, massive elite team. Like, you don't find yourself saying that, it doesn't roll off the tongue, right? Huge, efficient code base. You haven't said that one recently, probably. Long, successful project. Probably not. Actually, successful project, unfortunately, you didn't say very often either. Enormous, agile company. Very infrequent that you come across these things. And I did a bunch of research because, I thought I was going to get all Malcolm Gladwell on this thing and impress everyone with how deep I thought about this, but there's a whole bunch of evidence. This is just one thing that I found and cited in that talk. You can watch that talk if you really want to hear me speak for another hour at some point. It's online. But this one really resonated with me too, that, I think this way too, that there's a magic number of human comprehension that you can remember 7 plus or minus 2 things. And there's a little bit of debate about this, but it's somewhere in the mid to low single digit range where as humans we can just see and immediately recognize, remember anything, any combination of things. And it matches like the rule I've had since the 1990s of no method can be longer than 5 lines. I just arbitrarily chose that number and I've always told people that. If they have a longer method, I don't complain, but I always say that because I want to get into people's heads that you need these small recognizable chunks of work that you can think in. But the more I thought about this, I think there's a lot to be said for keeping things small, whether it be in code or systems, projects, teams, whatever. To me, though, the benefits of all this tininess are really just that they lead to a couple of things you can do. So if you have small things, you can throw them away. And I said that disposability happens at both runtime and at coding time. And immutable infrastructure is my version of the runtime version of that, where we used to be very proud that we would have a server. Like when I worked at GE, I was managing Sun servers, and I would go log in and type uptime, and I had one that was up for 2 years, and I was so pleased. But we were all terrified of that server because, we didn't even have something like Chef back then. All we did was log in and do things to it. And, one time it died, the hard drives died, and we all ran to the server room and literally had to reinstall everything we thought was on it because we were terrible system administrators. But it stayed up for a long time. So it was up for a long time. Long is bad because long makes fear at runtime for a component, right? And then this idea of disposable components. As I said, tiny components you can throw away. And by that I really mean the most agile code base you have is the one where nothing is permanent. Nothing has been around for a long time because you can change it. So we had rewritten 80% of our system on the Wunderlist backend, and it's fairly large. As I said, it's 100 something services. In a year, we had rewritten 80%, which told me, what if it was written in Rails, and there was a major new Rails upgrade that came out? Well, I know that I can rewrite it because I've just rewritten 80% of it, so it's very easy for me to do that. It's very easy for me to roll out a change to a Ruby security patch or all those things that normally you think, oh crap, I've got this big code base, it hasn't changed in a long time, I don't know what to do when I'm forced to change it for some reason. Much less, obviously, business requirements. So I would say that the mutability of a system, the ability to change a system, is enhanced by the immutability of its components, which sounds kind of backward, but it also maps to this idea. I keep seeing the people take the pictures of the slides. There, you can do that one again if you want. I'm just joking, you can't. Too fast. The system is the asset, the system is the thing. When we were in our board meeting and Matthias was freaked out that we were going to rewrite the system, he should have been freaked out that we were rewriting the system. Had we told him we were going to rewrite a method in one of the classes, he wouldn't have cared. He would have said, why are you telling me that? He actually would have cared because he would have said, you're a CTO and you're talking to an investor, why are you telling me about this? That's why we didn't tell him we rewrote 80% of the system, because we did it in these tiny chunks. The code doesn't matter. And this idea that people fetishize code is really on my mind now. And I didn't realize it until we finished this project and then we joined Microsoft and started talking to people about all their shared code and all the code of Word. Like we have meetings with the person who opened the editor and started typing the code to Microsoft Word the first time. You know, those are the people. That guy works on Microsoft Word now, amazingly, still working on Microsoft Word. And I don't mean that as a disrespectful thing. Like, can you imagine? That's a lot of years working on Microsoft Word. You are the person who made it. One of the things that freaks people out the most, especially when you get acquired, you go through due diligence, which means they really dig into all your stuff and they try to find all the things that might be problematic. And so they decided they wanted to buy us, Microsoft did. Then they did due diligence, and then they found out that not only did we have 100-something microservices, but they were written in 15 different languages, or I don't know, I make up the number, but it's something like that. I can't remember all the languages that they're written in, but they definitely include Ruby, Scala, Clojure, Haskell, Elixir, Go. There was one in Rust, some in JavaScript, like pretty much anything you can think of that you would maybe want to write a piece of code in right now. And at first, the reason that we did that, it was actually a reaction to where I had previously worked. I was running engineering at Living Social, and we had a very different culture there in DC, which was much more directive, where like you had to work not only in Ruby and Rails, but specifically this older version of Ruby and Rails because we were very risk averse. And I hated that. I also have hated for my entire career the moments where you stand around like talking at the coffee as a programmer about, man, I wish I could try out Rust, but we can't do it here because the CTO won't let me. I'm going to go look at a company that will let me do it. I hate that. It's a stupid reason to have to move to a different company if you like everything else. And it's also just a stupid thing to be worried about as a human that's trying to work, especially as a smart person working in a smart person's profession. You can't make your own choices. So I decided as CTO of Six Wunderkinder, I have to admit it was kind of dumb. I just wanted it to be, I wanted to do something interesting. I said the rule for us is that you can write code in any language you want, any runtime you want, as long as it adheres to a couple of rules. One is you have to find at least one other person who's interested in that because it won't just be you. Then it has to work with our monitoring system, our deployment system, our bug, our crash tracking system. I think that was it. So those things. And if you were like an intern and it was your first week on the job and you wanted to be the person who would introduce Haskell to the system, that's okay, as long as you follow the rules. Oh, sorry, the most important rule, it can be no longer than this. And again, I'm holding up my fingers in some small thing. Because I thought, if you write a system in Idris and it's down and I get paged in the middle of the night, if it's really small, less than a page of code, I can probably understand it well enough to either figure out how Idris works or just replace it and rewrite it and Go or whatever and deploy it. And so we did this. People took advantage of it. They did it more slowly than you might think. Like the guy who wanted to introduce Elixir waited almost a year because he knew he had the power to do it, but he didn't want to be the one to introduce it into the deployment system. Like Jan was talking about, each of these different runtimes has a different build system, all these different dependencies you have to set up in the infrastructure. And it was each developer's responsibility to set it up in the infrastructure like this. So given the power to do it, they were more conservative. But at the same time, he might be frustrated at the coffee and say, man, I really want to do Elixir, but I just haven't had the time to focus on it, or it hasn't been a priority. So that's what the conversations turned into, which I think is quite a bit better because then they're not blaming me. I like that. But it also gives people a sense of freedom. People are motivated by the ability to explore and expand their boundaries. So when you give that to everyone and you put the decision-making power with them, they feel more ownership in the process and less like malicious compliance. So anyway, that was the human reason that I introduced this rule. But what we got out of it was technically interesting as well. And so most of the time I just claimed that I did it for these grand technical reasons. One of them would be, if you write a service in Ruby and I write a service in Clojure, if we wanted to tightly couple those services together in a way that you couldn't detect, we would have to do something really, really difficult to tightly couple those services. Or we would just make like stupid, REST calls between them, of course. But really, you have to go out of your way to introduce tight coupling if you're working in a radically heterogeneous environment. You have Ruby, Haskell, etc. You can't have, for example, shared code. And oftentimes when I tell people about this, they say, well, how do you have shared code? Like, isn't that a waste? You've got all these different things. And I say, we don't have any shared code. Not at all, no. And I think that is a wonderful thing. Because think about what you do in shared code. Like, you have this idea that it's going to be great, and you're going to build one part of the system, and it's going to be reusable, and it's going to save you so much time. But really, you spend a bunch of time screwing around with the shared code. Maybe every once in a while, you come up with like one thing that's really meaty and valuable. But the rest of the time, what are you doing? Logging and crap like that, Like, just do it again. Not only that, shared code, I think, is a huge anti-pattern. Because shared code becomes permanent code. The reason that you write this shared code is so that you can use it one time. So then it becomes the golden thing. And it's like the anchor that's being hung to every single service and every single piece of application code you're writing. This stupid shared library. You have to figure out how to update it across everything. You're afraid to change it because there are so many dependencies all over the place and they're happening at runtime. Then you have versions all over the place. It's a mess. So I think shared code becomes permanent code, and the dependencies in a shared code environment are very real, and like they accidentally create this static structure. So what we did is we said, let's not have shared code, let's have shared services. And we literally, I think there's one piece of shared code we have, which is just for creating, like enforcing some conventions around how the services are called, and it's 100 lines, and we've written it in every language we introduce, so it has become one of the rules. But otherwise, no shared code at all. Everyone knows if they say, like, let's make a Ruby gem we can use through all the services, that everyone else is going to say, boo, you can't do that, and shame them out of the office. So then I talked about no shared code, but we have shared services. An example is like how we do logging, how we do metrics. They're all deployed locally. We don't use Docker only because we built a system very similar to it right before Docker hit, and it hasn't been worth going into the container stuff yet. But we deploy all these local services that you talk to with UDP for the most part. And those are shared services, so they get deployed on many different containers, many different servers. And then the way that our services talk to each other, I showed we had all these bubbles of things talking to each other, is through the most idiotic, obvious way that you could think of if you're doing a REST architecture. And that is HTTP with JSON payloads. So probably what you would expect. It's not thrift, it's not some low-level binary protocol. It's like maybe compressed if we remember to get all the libraries right. It's just really, really dumb. It's so dumb that you could construct in your head and type manually very easily what the payload should be, request and response for any kind of interaction in our system. Isn't this inefficient? Of course it's inefficient. But what we are optimizing for here is understanding the system. And an argument that I make is that the communication between all of the parts of all of the bubbles, all those components, is a very important part of what you would define as the system. So if you can't understand that because it's obscured or it's prematurely optimized, then you're making a mistake. And you're making a system that people won't understand and be able to change. And this all leads to the ability to be decoupled. Because if you have a standardized way of speaking, and I don't know if it said standardized, did it? It didn't, but a standardized HTTP REST protocol between all the systems. And it is convention. Like I could tell you a noun, and if you worked on my team, you would know exactly what all the verbs were and the paths and what the JSON looked like, that sort of thing. It means that you can replace anything behind those components. Even though they're slow, when you make the individual calls, they're very easy to change, and they're very decoupled, and this is the goal. So a quick aside. Do you all know who Mike Feathers is? Has anyone read the book Working Effectively with Legacy Code? Not enough people. Everyone should read this book, Working Effectively with Legacy Code. Because of my interest in the term legacy, Mike is one of the people that I consulted to say, like, how do you make legacy code? How do you make code that can survive? He unfortunately had too negative a viewpoint of it at the time. I think he was coming off of a bad project, so he didn't help me a lot. But I had him keynote at RailsConf several years ago. And one of the things he did is he showed an example where he put up a piece of Java code on the screen, and it was, a screen's worth of code, and it was pretty ugly. It had like case statements or something you wouldn't want to do in Java code if you're a Java programmer. And he asked the audience, is this good code? Like everyone's, slowly started saying, no, it's not good code. And then he said, what if I told you I looked in the version control history, and this code was created 2 years ago, it's been in production ever since, and it's never been changed, and it is being executed. Is it good code? And it made everyone think, like, well, why not? It works. No one ever had to change it, even though it sucks, and I wouldn't want to have to change it. No one had to. Maybe it's okay, right? I think that's kind of a controversial idea, but it's one that I have bought into since then, except now that I think about impermanence, I worry about anything in my system that I'm not comfortable changing, even if I don't think I'll have to change it, because the day may come when I have to change it. So I no longer buy into this, although I think the line of thinking is good. That's the caveat. So as long as you can somehow replace it, it's good code. That would be what I would add. So immutability, if it's not clear yet, in at least my worldview, immutability and disposability are sort of the same thing. They go hand in hand. Any of you do functional programming, like Clojure, Haskell, one of those sorts of languages, Scala? No functional programming people. Ah, there you go, thank you. You're just shy. Functional programmers are shy. In good functional programming style, you don't have to do it with functional programming languages, but in good functional programming style, you tend to use very small scopes. And part of the reason for that is the scopes are immutable. Like you typically can't reassign a variable. It's not a variable, it's just a declaration. It's a name that you assign to a value. You can't change it. Which makes it very hard to write a long method or a function because you can't reassign anything, So in good functional programming style, you tend to have these tiny little immutable scopes, which are also disposable. And that's the sort of important thing that makes it work. It's okay that we assign name equals Chad here, because that's only going to live for the moment that it gets executed, and then it's clearly out of scope. No one else can reference it, and it's gone. That is actually most of the power of functional programming. So if you were thinking about maybe checking out functional programming, that's why to do it. It has these disposable tiny scopes, and you can't get confused about variables and what their values would be and how they would be set. So this immutability leads to small scope, and they kind of go together. So one of the other things that I have heretically talked about, I probably shouldn't use words like heretically in a room full of people who don't natively speak English, but shockingly talked about maybe, is that I think testing is a design smell, like a code smell, design smell. Which means if you have this like fetish for writing a bunch of tests, it probably means your code is so complicated that it needs a bunch of tests. That's the problem. If you would write your code so that it's so simple and so small that like you can throw it away, like I'm talking about, it would be a waste of your time to actually write tests for it. Like Kent Beck talks about, test anything that could possibly break, which is a fun thing to talk to him about. He's the one who coined extreme programming and a bunch of other stuff, and TDD. I sat with him once at a workshop where he was instructing, and he looked at my code and he said, well, have you written a test for this? And I said, should I? And he said, test anything that could possibly break. And I just sat there thinking, I don't know if this can break now, I'm afraid, But if you write code where the goal is there's no way in hell this can be wrong, then time spent testing it is a waste of time. It's a weird fear reaction. You could say, well, testing is not about actual validation of the code. And then I would say, okay, so what you're telling me is you need a test to explain this tiny piece of code because it's too complicated somehow to understand. No, you don't. Write code that doesn't need tests. And when you do that, you can test the stuff that actually matters. So I run my tests in production, and I do it as metrics. So we have metrics, and I said when you introduce a new language into the system, you need to hook into our metric system real-time metrics for all of the things that matter in your code. Well, what matters? Anything that could possibly break, right? So you're measuring business events, you're measuring performance, all the stuff you might care about in the code is getting shoved into this metric system. The difference between these two approaches, one, of course, your users will feel it if you screw up in my version. That's something that might be better in testing if you actually believe you can catch the bugs in your tests, which you cannot. The other one, though, is that tests optimize for permanence. And I know all of you who have done testing and test-driven development have felt this, especially acceptance tests, where you've written all these tests and then you want to do refactoring and you realize, well, shit, now I'm going to spend all my time refactoring my tests and like I don't even want to do it because all my tests are failing and you're totally pissed at the end. What I do is I throw away the tests at that part. Metrics, on the other hand, they don't provide assertions. You can configure those assertions anywhere you want. You can measure them any way you want. You can look at them on a board, whatever. And they are about things that actually matter at runtime. So if you change your code, you don't have to go change the metrics. They're just in the code. You don't have to change the things that are providing the monitoring. And so I would challenge you all to stop writing tests immediately. No more unit tests, total waste of your time. Spend all of your time on monitoring. Please tweet that. Tell your bosses. This idea also applies to organizations. And this is something I drive my own team crazy with. I just did a presentation for my team, which was about how we make decisions about org changes. So any of you work in a team that's like bigger than 100 people, or a company that's bigger than 100 people? None of you? Oh, some of you. I just have to ask twice every time. Yeah. You're probably annoyed when you see this happen, or you're like freaked out or whatever. If it happens too often, then you start thinking, why can't they decide? Like, why didn't you just pick an organizational structure that worked and stick with it? And the reason is because it's against the laws of nature. That's why. Because static, permanent organizational structures suffer exactly the same problems as static, permanent code. If they can't be changed, like Martin Fowler and some other people, I'm not sure who really said it, say, if you can't change your organization, which is fun, but it's true. Here are some stats about project success. This is the Standish Chaos Report, and there's probably at least one person here thinking, yeah, that's bullshit though, but actually it's a group that goes out and it does surveys of large projects, and it collects a bunch of information about them, and then whether or not they were successful, failed, or challenged. And in case you can't see colors, successful is the 39%, failed is the 18%, and challenged is the 43%. Challenged means significantly over time and or over budget, which to me is a failure too. So I think it's really 60% are failed, and the rest, 61% are failed. The reason I said you might be thinking, yeah, that's bullshit, is because some people question their methodology, but whatever. It doesn't matter if it's exact. We all know this is right. We're software developers, right? It's true. Software projects suck, and we're bad at them. But look at this. This is where you start to say, wow, small projects versus large projects. 76% of small projects are successful. Why the hell are you ever doing a large project? It's ridiculous. Here it is. Never do it again. Next time someone wants you to do a large project, absolutely not. No tests, no large projects. That's the mantra. But it's amazing. Why are small projects more successful? Well, you can scope them, you can understand them just like you can understand a small method or a microservice, because it's just right there in front of you. Like, if I asked you all to estimate how long will it take you to write a new operating system for the Samsung Galaxy Note 7, you would say, can't do it because it'll explode before I'm finished. No, you would say, I have no idea, but years probably, I don't know. You would overestimate, but then that would be too low. But if I said, write a function that reverses all of the words that I just said and then prints them in Japanese on the screen, you could say, yeah, probably that'll only take me 3 or 4 weeks because you're software developers. But you didn't catch my joke. I I was telling someone I was writing to my team in all caps today on Slack, followed by a smiley face, which makes everything okay. Why does it take so long to do everything, software developers? And oh my God, it's just a to-do list. Please. Smiley face. Wink. So this is interesting. And I would say that you can take this idea of small projects and say, at least the way I do things, usually a project means the new formation of a team around the project. So if you're always doing these small projects, then the teams are also small and impermanent. They keep coming together and coming apart. And it proves to you as an organization that you can withstand change and you can be agile. And it also gears you up for doing these small things. So it feels like a sort of universal idea. Now, just a note really quickly about languages, talking about the radical heterogeneous thing that we're doing. Oftentimes when I talk to people, like even members of my own team, would always assume that, yes, we introduced all these different things, but surely we're going to just start standardizing on one or two, like Clojure and or Scala, so we can just all be on the JVM or whatever. And this is one that maybe even most of them are sort of gravitating toward. I think it's just natural that a group will at least form camps, and it feels like we have like a little Go cluster, Golang cluster, and a little Java, Scala, Clojure cluster of people. And that's where people are kind of lining up. And it mostly is about functional programming versus whatever Go is. I don't know what you call that. I don't think this is good. I mean, it's funny because I said I wanted to encourage choice in the people and I wanted them to feel free. And yes, the idea of heterogeneous, like all these different languages and runtimes is crazy. It really is, like nothing I've ever heard of. But now that it's going away, naturally, I want to kind of force it to be like that. Because what I'm afraid of is we will naturally fall into the rhythm that happens when you standardize on one thing. Well, it's not changing all the time, therefore we don't have any proof that we can change. Maybe our people will all become Scala people, and then they won't be able to tolerate doing Elixir or whatever the thing is that happens next. Or for us, maybe it's C#, F#, Link, etc., all the Microsoft technologies. Maybe they'll start thinking like Scala people. And maybe they'll start writing shared code because, well, it's all in the JVM anyway. We might as well write some shared code. And maybe just naturally, we will create a stasis in the code, a lack of dynamicity, a lack of agility in the code based on this other seemingly unrelated choice. So it's not really even just an accident or a product of history now that we have this heterogeneous code base. I would want to keep injecting this thought into the team over time and not let them choose to stabilize. Microservices is not an architecture. That was all. Microservices is not the architecture. I have nothing to say about that, but people say like we need to go to a microservices thing. We need to do microservices, and it's like they forget that really is like choosing that we're going to have small methods. Okay, now what? We're going to have small methods. What is the system? What is the architecture? You need to build an architectural point of view of your own, and microservices are really just like a way that you like to accomplish it, but it's more of an implementation detail. And small is not the goal. The goal is what? The goal is decoupling and understanding. And ultimately the reason for that is because you want a healthy, long-living system. You want a system that you can change. That's what healthy is in software, because if you can't change it, it dies because someone like me is hired to destroy it. I usually put software euthanizer as my title on my presentations. Euthanizer means mercy killing, like if a dog is sick, you kill it, That's pretty sad. Systems that survive are made of components that change. And maybe one of the most influential lines I got in my entire career, both for work and life, came from the extreme programming movement. If it hurts, do it more often. So if change hurts, do it more often. And I think it's pretty much a proven fact, and all of us know it inherently, that change hurts in most software. So if we do it more often, even when we don't need to, throw our code away, we get better results. Impermanence leads to decoupling, longevity, and agility. By thinking about impermanence all the time, you will naturally end up with these three things. And that's it. Does anyone have questions? Yes. I will give you my microphone.
I have heard, do you agree? I have heard that with the SPAs like Angular and React, that they are up very much in fashion now. It is now made the same mistake in the front end, which was done in the back end, because these SPAs are also monoliths in the front end now. Do you agree with this, or or do you think it's not true?
I doubt that these things have to necessarily lead to monolithic applications. In the same way that like Ruby on Rails came along and everyone built their monolith on Ruby on Rails, you didn't have to. The initial version of our Wunderlist 3 backend was Ruby on Rails, but it was hundreds of services. I think that all of these front-end frameworks, like I noticed something when I started doing Rails back in 2004. I was already an object-oriented programmer and really into like design patterns and doing good code. And when I got into Rails and I saw the structure that it created for me, I forgot that I was a programmer and I just started filling in lines and doing stupid stuff. Like I forgot everything I knew. It wasn't the fault of Rails, it was the fault of me getting used to this new environment. And I think that's what's happening to some extent, is that people are getting into Angular, etc. And they're just following the tutorials and then growing their monolith without like taking the time to step back and say, how could I separate this out?
Okay, and another question. I also heard that if codes are not tested, they are already legacy code, codes without tests. So what I wonder is how you make sure that if you change it and throw it away, how you make sure that the code that is still working without tests.
So all code that is written is legacy code, actually, whether it has tests or not. So I agree that the code without tests is legacy code, but so is the code with tests. I don't know when I have tests if they're actually catching all the bugs either, or if they're catching the changes. So if I replace the implementation of a method, how do you know that the test was correct? You don't, because the tests themselves are legacy code, right? So there's a little bit of like circular thinking, and I think it's a fallacy to believe that tests are truly helping you validate your code since they're written by fallible humans. My answer to your question of how do I know that the functionality is the same is I have metrics in the system and I have alerts and I can see when I deploy. Typically we deploy in the canary in a coal mine fashion, which means we can deploy parts of our servers to the new version without changing the others. And so you can see increases or decreases in error rates, whatever error rate means. Maybe it means not enough lists are being created in Wunderlist. And so you can see the real business effects of the changes that you're making before you roll it out to the whole user base. So we use metrics in the same way that I was saying metrics are the replacement for tests. That's how we think of them too.
Okay, thank you. Thank you.
Does anyone have a question?
Question. Hi, Chad. First of all, thank you for your presentation.
Ah, there you are. You're welcome. Thank you for paying attention.
Yeah. First question. At the Wunderlist, can you give an estimate how many microservices do you have?
Yeah, like 150 or so.
All right. Another question. How do you mitigate the footprint overhead for the runtime, for the operating system if your microservices are small? Is it a problem that, for instance, your operating system runtime takes more place in memory and in the footprint as your microservice code itself?
Yeah, it's not a problem for us. It could be for someone. You know, if you had no money to spend to run your infrastructure, then you'd have to think about that a lot. For us, we had already been at a level of traffic that there's no way that we would never be thinking about that level of detail. It's more about keeping the system up, especially for bursts and App Store focus features or marketing pushes, you know, surprise appearance on a television show, that kind of thing. So what we did was We optimized, like when we did this big change of the internals of the system, I shouldn't say big change, this many changes that led to a big change of 80% of the system, what we were doing was taking our Ruby on Rails versions of the microservices and rewriting them in Scala and Clojure mostly at first. And in doing that, we were able to sometimes go from like 30 servers running a service to 3 servers running a service. And technically it could have been 1 server running a service, but we had it running in multiple availability zones for redundancy reasons. So the short answer is there is a minimum cost that we could get down to as a group, the way that we organize things, which would be 3 of every service, so it would still be a few hundred servers. That just wasn't an important factor because we needed enough anyway to deal with the capacity. If we were worried about that, we probably would have started combining things on the same boxes. We started looking at Docker and all the container technologies, but it never surfaced as something that was worth doing for us.
All right. Last question. This rewriting for the whole framework for a whole your platform is essentially a big project. How do you keep it small?
Oh, you mean rewriting the architecture like we did?
Yes, that's right.
That one's harder. We actually did it in phases. So first thing I'll tell you is we did it the wrong way. We did it the slow way, or the scary way. And I fought against the way we did it, but I fought with our CEO, and he won. And he was right. It was good, what we did. We did not keep it small, but we did experiment with the new architecture in the old code base. So starting a couple of months after I joined Wunderlist with the old monolithic code base, we started adding features. We added payment stuff, commenting files, these sorts of things. And when we did, we implemented the new version of what our synchronization protocol would be. And we started with the microservice architecture, but just for those services so that we could test it out. So by the time we started the big project, we already had some good proof that it was going to work. Then the next step was, since we had a multi-layered architecture, we started building clients in the monolith so that instead of talking to the database directly, they would talk to one of the new services, and it would talk to the database. We wanted to do that with all of the services, so eventually the front end of the Wunderlist 2 REST architecture would simply be REST calls to our new services. We didn't have time to do that, but we did it for the most important parts of the service, which meant when we launched and we went live with the full new thing, much of it had already been in production for real clients for several months, so we had a lot of confidence in it.
Okay, so you did keep hybrid releases, so part was according to old architecture, parts according to new.
Yes, and then we had to work very hard to isolate any of the dependencies in the old architecture, because especially in a dynamic language like Ruby, but really in any monolith, it's very hard to find the dependencies inside one runtime. So we were very careful. It was painful to isolate those dependencies so that we could talk to the services and not the databases.
The last thing, how did you convince your investors and your management to be consistent with the changes and to pull it to the end? Because they might tell you, yeah, forget this, just ship it. We don't want to.
Well, we were lucky in that the main feature of the rewrite was that the back end would be fast and we would have real-time synchronization across all the clients. So Wunderlist is a to-do app, but it's a collaborative one. You know, I can share a list with you, and if you have it open, it will pop open within less than a second usually, and everything we do is in real time. That was the feature that they most wanted, and the one the CEO was really driving. And basically, no one told him it was possible with the old architecture, so he knew it was not possible. And he knew that the old architecture was dying until those of us who came in to do the new one arrived at the company. So we were lucky that we had both a very big technical challenge that had a business impact and that we had built credibility on the previous hell of supporting the old architecture.
Yeah, thank you, Chad.
You're You're welcome. Do you have any more questions, though?
No more. I give a chance to others too.
Okay.
Well, up above there's a question.
Hello.
Hi, I have only one question. That's good, right? So, thank you for your talk. There is an idea, an evil idea of code ownership. So, if I build in my company this kind of killable code, how do I deal with respect or disrespect to my fellow co-developers?
That's a really good question. I remember the day someone rewrote my Haskell service and threw it away, and I was really sad. And when I felt like that, the emotion welling up in me reminded me that I wasn't supposed to be sad. I was supposed to be happy about that moment. And at that point, I was already general manager too, so it probably didn't make sense that I own that module. It is a problem, you know, and I think in a way, it sort of maps to Martin Fowler's "if it's hard, do it more often" thing. If it's hard to change or replace someone else's code on your team, then it might be a good idea to introduce a process that makes it happen so frequently that you have to work through the psychological ramifications of it. And I would say now we don't really have like code turf like that anymore, which is a healthy thing for the team.
Hi there, thanks for the presentation. My question is, you mentioned the 150 microservices, and I'm sure you don't deploy them by hand, so what is your experience or your recommendation in terms of orchestration? Would you use something like Rancher, or did you develop some custom ways to deploy and to manage the whole scenario?
Yeah, do you remember when you first heard about Docker? Do you remember that moment, like the time period?
Yes, I do, actually.
We built our system right before that.
All right.
So
Okay.
what that means is it was working really well, and then we heard about Docker and thought, well, damn, that sounds good. I also wrote a really nice Java MVC framework in the year 1999, right before Struts came out, and we used it for hundreds of apps at GE. And I definitely should have used Struts if I had known. We built our own thing. It's called Wake, actually. And the reason it's called Wake is a stupid play of Wunderlist and Make. It started as a series of make files, which is not a good idea. I don't recommend going down that path. And now it's a convention-driven set of shell and Ruby scripts that automate stuff on AWS. So to do a new service, you have to create one JSON file, and that's it, and it does everything for you. But I wouldn't do that anymore. You know, I would go use one of these systems that everyone's using these days. Probably not the newest of the new, but you know, whatever was cool 6 months ago is probably the thing to use. But yeah, it's very important. Like if you're going to do, it's one of the frequent criticisms of microservice-based architectures is, well, now you have to make an automated deployment system. And I always say, well, you should have done that anyway, so good. Go do it, even for your one service. And I really stand by that. It's silly not to have that if you think you're ever going to do anything with the code base.
So if you preceded those techniques, what's the next big thing you're maybe already working on we don't know about yet?
I have to be honest, I'm general manager now, which means I write email and work on presentations. So I can't tell you the next big thing we're working on with infrastructure, although I can say that we're going to throw everything away again. That's for sure. I probably could have told you that even if I didn't know, because that's always going to happen. But we're going to throw it away, and it's not going to hurt that much. I have questions for you then. How many of you are doing microservice-y things at work? And how many of you want to be doing it? So not too many more than are. How many of you are writing code in Java daily? All right, how about C#? PHP? Wow, it's a really mixed group. Node? Idris? J? COBOL? No? Okay.
We have another question.
Oh, we have another question. Hello.
Hey, Chad.
Hi.
You said you're a musician.
That's probably...
Till now or till 20 years ago?
Now again, sort of. So I didn't say where I'm from or anything. I figure it's boring to introduce yourself in a talk, so I don't ever do it. But I was living in Berlin until a couple months ago. And then for family reasons, suddenly we had to move back to Memphis, Tennessee, which is Probably like slightly cooler than, I don't know, let's see, Rostock in terms of the tech scene. Maybe, I don't know. But that happens to be where I lived like until 16 years ago, where I was a professional musician for a living. And so it's interesting going back. I was a saxophone player for a living. I play lots of stuff, but going back, I see all my friends that were all young then. We were all like the up-and-coming musicians. Now they're all the best musicians in town, and I'm still maybe an up-and-coming musician. So they've all invited me to play on their gigs, and I don't know if they hear me play, they might not let me anymore. But we've restarted some bands, but it's mostly things that no one wants to hear, so it'll be okay.
So how did you progress and learn to develop Wunderlist?
How did I progress and learn to develop Wunderlist? You mean how did I go from musician to that? When I was playing music on Beale Street in Memphis, Tennessee, the blues music, I was really into Doom. This is a tattoo of God mode and Doom. That tells you how much I was into it. But I got this when I was 40, so it's not like I was a stupid 20-year-old saying, oh man, Doom is awesome, you know. But I was so into it that I thought it was just so beautiful. Like I called it real-time action-paced chess or something, you know. I wanted to understand how it works, so I started learning programming at night after my gigs. So I'd go home at like 3 after playing in the bar and get on Gopher, which is how you browse the web back then, and look up stuff and like ask stupid questions of my friend, and I just got so passionate about it. I think the reason that I was able to progress quickly is because I came from the music industry. No one is in the music industry to get a good job. Everyone is there because they believe they can do something great, or else you don't bother, you know. I mean, eventually you end up on a cruise ship and you realize you failed. But before that, you think you can be the best, you think you can make an impact. So when I switched over to the computer industry, I just thought that. Like, that's why you're in industry, that's what you do, you know. And so I think for me, I leveled up really fast because I set my sights on, like Kent Beck, who I mentioned. I met him, and I left this session with him, and I told my coworker, I have to work with people like that because I felt so much smarter this week being stimulated by people like that all the time. The only way to work with someone like that is to be like that. So that's when I started figuring out how do I speak at conferences and write books and write blog posts, although they weren't called blog back then. It was like weblogs or whatever, articles on the web. And I just learned stuff online on the internet. That's it.
Thanks.
Sure.
I think I saw another question.
Okay.
Chad, the merits of microservices are quite clear to me now, but how about the downside? How about the pitfalls, the dangers, the no-nos? What would be, for example, the 5 things to avoid when implementing microservices?
Well, a sort of stupidly specific one is you don't want them calling each other. You need to have a clear path of execution, or else you can just get into, it's very easy to get into circular loops and you can't figure out where performance problems are. I didn't talk about performance a lot, except to say that it was slow, but I left out the part that in aggregate our system is way faster than the old system and very easy to isolate. I would put them on separate servers, whatever that means to you, wherever possible, separately monitorable compute instances of some sort, because when you put them all together, they can interfere with each other in ways that you can't predict. What else? I don't know that I haven't already said. I mean, it's not really a pitfall, but you can't just start doing it. You know, you have to, like, you don't just say, I'm going to do microservices and I'm going to get all these merits on day one. There's a lot of an investment. So if you try to start thinking there's no investment in it, you're going to be wrong. There's a lot of work that goes into kind of like base infrastructural overhead that's higher than what you would typically have. I would say that it's slightly higher than what you should have typically, but it's much higher than what most people have typically because they don't do anything that's automated. Thank you.